Good afternoon, and thank you for coming to this webinar session today for the heater project. We're looking at the heat solutions for rural areas. My name is Robert Clements. I want to introduce you to the team we have here today. So we've got the Housing Executive, we've got Ulster University, we've got the Letterkenny Institute of Technology, and we've got Oulu University from Finland, and you're all very welcome. Today's aim is to look at the previous projects which we carried out and to see what lessons we can learn with a particular focus on heating solutions in rural areas. As you see, this is a cluster of 4 projects across 3 different regions of Europe, and the total fund is £153,000. The heater project itself, just before we start, we want to look at the common challenges of fuel inequality, looking at fossil fuel dependence and how we can decarbonise in the medium to long term. We're developing a network. We're going to have a series of 3 to 4 webinars, and we'll have a final conference in June of this year. The end result is trying to empower rural communities how to understand about fuel inequality and getting off fossil fuel and decarbonising for the future. As we see, energy prices are now at an all-time high. Locally in Northern Ireland, our regulators told us we're going to have high energy prices for the next 18 to 36 months. So more than ever, we need to look at energy poverty, fuel poverty, and our dependence on fossil fuel, and how we can find sustainable solutions and make energy efficiency a key priority. First of all, I want to talk to you about the Handiheat project. This is a project that I was project lead on. It's presently still ongoing, and we had 2 pilots inside the project, which I really want to talk about. So Handiheat project, it was set up 3 years ago. The aim was to reduce carbon emissions and look at energy efficiency in rural areas. We looked at a policy review, we done a benchmarking exercise. We have 2 pilots, one in Finland, one in Northern Ireland, and then we're looking at a toolkit which we'll be using more during the heater project going forward. The aim is to protect rural communities from price fluctuations in energy and to improve social well-being and quality of living. The first pilot, which we're not really going to touch on much today, was an off-gas grid biogas heating solution in Finland. The aim was to have a CHP unit to run for small direct or district heating for around 20 units. And we're getting the results for that will be coming out at the end of March. Again, the aim was to have decarbonised heating to keep energy bills down and to improve and keep thermal comfort going. But the project we're going to talk a lot more about is the one that we had in Northern Ireland in rural Fermanagh. It's the first time in recent memory we have looked at the retrofit issue and the low carbon heating. We looked at using social housing. We're looking at measuring the data over a 1 to 2 year period. It is very householder focused. We're looking at the capital costs, the householder bills, the thermal comfort and the carbon emissions. Unfortunately, the project was hit right in the middle of COVID. And although we have data, we have got data for 2 winter periods, and we're presently going through the 2nd winter period at the moment. In the Handiheat project, we looked at energy efficiency first. So we wanted them to find a reasonable level of energy efficiency improvements and keep it under £10,000. And the actual fact that the total cost of the measures that we put in cost around £8,000. We want to try and get the SAP, the thermal efficiency up to a SAP band C, primarily through cavity wall installation, loft installation, fitting windows to a passive house standard, in other words, using certified passive quality air tape, and non-intrusive air tightness measures where possible. The end result, we didn't actually reach a SAP band C with all this, but we reached a very high band D between 65 and 69. And we also looked at air tightness, and we improved the air tightness from a range of 10 to 12 down to 5 to 7. So in short, energy efficiency and air tightness was a key pillar at the start of the project. As you see here, this is the cavity wall installation, been extracted and put a new cavity wall installation in. Here's the loft installation that we put up to no more than 400 millimeters. We fitted the windows to a passive house standard, and we put aerogel in it as well. And we tried to look at the cold bridging areas and put more insulation in that there to stop cold bridging and improve the air tightness coming into the property. We also we had 2 main models. One looked at low carbon heating with the hybrid with oil and air source heat pump, and then the second used power generation and power storage. First of all, here we used the grant hybrid heat pump, which is an EvoLink, which is the small box in the middle. It has a 6 kilowatt air source heat pump, and then it has a high efficiency hot water cylinder as well. As you can see, the time clock was a local product from Climote, again, because it's functionality and it's very easy for people to use. This is a system which was fitted. As you see, there's the air pump with the fan on it, your existing oil boiler, and then your EvoLink up at the top. Your radiators were increased by 50% across the whole house to try and have a greater area to put out the heat of from the heat pump. The effectively aim at the start of the project was to try and give more primacy to the heat pump and then to use the oil boiler in colder weathers. The initial thoughts from the first winter was to try and have all heating below 3 degrees to be used by the oil boiler because it affects the coefficient of performance. But actually this winter, we haven't got the results in yet. We've increased the temperature to +5 to try and get more use of oil because we're using very, very little oil in the 2 houses which we're using. The second project we had was looking at energy generation and energy storage. This here involved 11 kilowatt battery and a 2.5 kilowatt solar panel, and then using electric heating with it. Effectively, what is shown was that over the summertime, there was a lot of export. The tenants' bills were down to around £5 per week. But there's that very much a measurable reduction in carbon for it. But yes, the final results this year will be coming out at the end of March, and we got the final report. Measuring the data was very important. We have all the different system providers have got data loggers, and that all feeds into Ulster University. So Grant data logger, Sonnen, we have got our own electric and heat monitors, and then we've got the Climote as well. The plan is all this data will be available at the end of the project, which will be coming to an end at the end of March, although the kit will stay in after that for our heating season. The initial feedback, and this is actually feedback from last winter, we haven't got the feedback in from this winter. And the hybrid, they were using around £13 to £16 extra in the use of their electric, but that's offset by savings in oil. We're able to look at their previous builds, we're able to look at the current data on the houses. Going forward, in our next project, we put in live monitoring data on which we can see the equivalence of the 2 things balancing out. The heat is different. It's better for the planet. It does feel warmer, particularly with the battery in the PV houses, and the air tightness had reduced dramatically from between 5 to 7. And in context, a new built house will have an air tightness average in around 3 to 5. So getting between 5 and 7 is definitely good news for spending £7,000 to £8,000. And as we see, the carbon reduction is cut down by a half. Again, this is some initial summaries, and I'm just trying to give you more of the highlight things, some of which is maybe fairly obvious. The capital cost of the heat pump and additional insulation is a lot more than just status quo. We're spending £7,000 to £8,000 on extra insulation, and then there's the cost of the heat pump. The heat pump for this here costs €3,500, and that would be the ex works price. The additional insulation, which we've talked about, but we do believe, on fabric first, we do believe in energy efficiency, and really our current thinking is at the moment we're still trying to develop decarbonised solutions, but we do know solutions for energy efficiency, and typically these houses are only losing 2 degrees heat per night in January. That was just looking at data over this last month. So, and we've got air tightness between 5 and 7. So our implication of that is by spending under £10,000, we are making a marked difference in energy efficiency, and that's something that we should be and could be thinking about doing first. The householder bills area analysis shows an equivalence between the oil cost and the electric cost, but that does not take in the fact we've spent a lot of money on energy efficiency and the capital costs not included. So that's very much a householder focused issue. So it is there. Just some issues about perception. This is more about behaviour change. And this is looking actually at our project, which we're just about starting. Whenever you convert from oil to hybrid, the tenants do not appreciate the cost of the oil heating. So typically we're seeing oil usage previously anything from 25 to 35 to 40 litres per week in an average size social housing. But then people who have got a gas to gas hybrid appreciate, because they're spending the gas top-ups every week. So that's a consideration, is that people do not know how much money they're spending on the product beforehand. But again, with oil monitoring before and during, you can explain that. That's very much a behaviour issue as opposed to a technical issue. The thermal comfort has increased. We're able to look at the data, but there is a perception about thermal comfort. So whenever you put in low temperature radiators, as opposed to the status quo, the immediate view of the householder, oh, this house is colder, even though the ambient temperature is not. What we have found in looking at 15 houses only, I'll admit, the condenser boilers people are using are not using them properly. They're not condensing them. They're basically, the heat exchanger has got the temperature up, and this means that they can blast out heat, and they can blast out heat through the rods. And the consequence is that they're not condensing the boiler, and that's not efficient, but it means they're using them as a previous boiler. That's definitely an issue, because we're now trying to get them into an idea of using low temperature radiators. So if they were using them properly, it would have been better. We're actually looking at that at the moment, because we do think that is definitely a much behaviour change issue. A key thing for us is tariff change. If we don't have tariff change, you'll not have electrification of heat. Now, we have modelled on the fact that these houses in Fermanagh did not have a tariff change, but we've modelled that into the data. But we do believe an economy 7 or an economy 10, a system that is going to be cheaper at a certain time of the day, that we can preheat the house, for example, in the morning, is definitely the way forward. Generation storage has been very simply worked. It's a very good success. Again, there's a cost to the PV. There's a cost to the electric storage. But again, simple to use, very autonomous for the householder. But the two key issues coming out of this, that again, very initial, very broad brush, is technically this stuff works. It works if you put in insulation. It works if you put in tariff change. But you must have tariff change, and you must have behaviour change. So you need to make the householder understand what they're paying. You need to make the householder understand about their radiators and about the temperature in the house. And that is just a period of education. And that's something that we didn't think would have been as profound, but it is definitely a key issue in the pilots. We presently are just in the middle of starting up another pilot in Oulu, effectively as an evolution of this, and we'll be giving more details of that out later on in the springtime. But I want to thank all our partners to date in the Handiheat project. Ulster University, the electric storage company, who are 2 associate partners. We have got MPA, who's funding us. We've got Climate, CFM contractors, Grant, H&A, U-Generate, and our local DNO as well. And thank you very much for all the support that they're providing and still provide to try and find solutions, which we are working on the key areas of allowing our tenants to have heat at a reasonable cost, keep their thermal comfort, and reduce their carbon. And that really is the summary of that. I'm now going to hand you over. I think we're doing questions at the end, Amy. Yes, I think we are. I'll hand you over now.
Just do questions at the end, Robert. That's grand.
Dr. Nick Timmins. Nick is the academic director at Letterkenny Institute, and he'll talk to you about the pilot which he carried out. So over to you, Nick. I'll just stop sharing.
Thanks, Robert. Thanks for the promotion there as well. I'm not actually the academic director of the Institute, just a WiSAR Lab inside the Institute, but still sort of had a good ring. Thanks very much for that, Robert. So basically, I want to talk a little bit today about another MPA project, which is part of the heater, the overall heater project. And the heater project really is about looking at these MPA projects, which are either approaching the end or have been completed, and it's a little boost to disseminate the results further. So just to give you a little bit of background, this project has been running for over 3 years. It will end in March 2022, so it will end next month. We did get an extension due to COVID. But it's a 1.65 million project. It has 7 partners, and you can see there ourselves, Donegal County Council, Derry City and Strabane District Council, Oulu University of Applied Sciences, the Syntec Narvik Research Centre, Iceland Energy Agency, and the Faroe Islands Environment Agency. That was a picture of all of us. Some personnel changes since then, because of the last time we got together was in Iceland over 2 years ago. But we are hoping to get a physical end conference towards the end of March, and we're planning that for Finland in Oulu. So we're planning for a face-to-face. If not, we have to move to online, we will. So again, fitting with the energy priority of MPA, the MPA region, the Northern Periphery and Arctic region, is about rural areas and their energy priority. In these rural areas, we still have a prevalence of fossil fuels right across our home heating, electricity, our cars, and this project is to look at ways in which we can share information and come up with solutions, develop pilots, which will help influence change. And a bit like what Robert was saying, change in people's attitudes as well as change in the technology. So those are some of the results that we had to achieve, and I think we're well on our way to achieving actually more than that. But what I want to talk about today really is we had 7 pilots, and I couldn't talk about them all because we didn't have enough time. So under the theme of heat, I chose three pilots, 2 local to here, one in Donegal County Council, one with Derry City and Strabane District Council, and the other with the Energy Agency in Iceland. At the end of the last slide, or second last slide in the presentation today, we'll list all of the pilots. And if you want information on any of those pilots, just please contact us. Sorry, I've just gone a little bit ahead of myself there. So the first pilot, Donegal County Council, was to retrofit Milford Public Services Centre and Community Library to get it away from oil, reliance on oil for heating, and to move it into renewable energy. This project was run by Pater Espy, who works in Donegal County Council. So basically there's a symbolic picture here of the oil tank removal beside our SMARTRenew poster. And they implemented a solar PV array with a just under 5 kilowatt hours, air source heat pumps with 184 kilowatt hours. And of course they had to tighten the efficiency of the building. And there you can see the projected costs there, and then the savings in CO2, pictures of the solar panel and the contract being awarded. You can see here the air source heat pumps upon delivery, and put in the fabric upgrade, cavity insulation, and here's pump controls to the building management services. But also some smart technology was used with apps. So on the left here, we see the solar PV smartphone app showing us the generation quantities. And then on the air source heat pumps, what the air source heat pumps used in terms of electricity. So it's been successful, and it's still a learning curve for the council. Things weren't quite as efficient during the summer months as they thought they might be. And that was due to really they sort of switched off their heat pumps earlier. But you can see these diagrams here. You can see the generation from some solar energy through the increase here through the summer months. And then on the lower graph, we can see the consumption of electricity through the period from January 21 right up to September 21. Just on some conclusions before I move to next day, I'm very pleased with the energy savings that they've made already. And they have one of the aims of these projects is to influence opinion and to expand from beyond the pilots. We're pleased to say that Donegal County Council are beginning to implement this solution on their other council buildings as well. So we're delighted about that. So moving on then to the second pilot that I will feature today, which is the Derry City and Strabane District Council, which under Leo Strawbridge was our partner, is the energy manager there. They implemented an intelligent energy management system or heating management system for Harbour House, one of their council offices in Derry. And they used this, they used a technology developed and run by a company in County Antrim called HeatBoss, which provides up to 30% wireless heating saving or saving through wireless heating controls, with lots of advantages in terms of bespoke heating for rooms and automatic control of areas and setting schedules for heating. We'll look a little bit at some of those details. So this is the old heritage building, the Harbour House. So obviously a building like this, you can't be drilling walls or putting in wiring. And this system is a wireless-based system which allows neat retrofitting without any damage to the infrastructure. So several Wi-Fi enabled devices which allow effective control of the heating system. So all of the radiators are fitted with a wireless valve so that the heat of the radiators can be turned off and on when required. There's an interactive thermostat in each of the rooms. Boiler controls have been fitted then to allow the HeatBoss Wi-Fi hub to interact with the boiler when there is a demand for heat or demand for less heat. These devices then allow staff to control the heating with use of thermostats or an interactive app on the web. And the Wi-Fi thermostats then collect temperature data also, and so which can be displayed. The history of this, the heating in each of these rooms can be displayed on the app. These controls also will link in with the building management system, and staff can control heat in each room using the Wi-Fi enabled thermostat or through the schedule, as I've mentioned. Outside of scheduled heating times, the thermostats can then be used to boost the temperature in a room when required. And then all of the data is gathered. So some pictures there of the thermostats. So the challenges that they were addressing here were looking at reducing high running costs. And so they were able to reduce the heating consumption by 30%, only heating in the rooms that were required to be heated and maintaining the temperatures well within the limits. It also provides customizable comfort. So occupants of different rooms can have their chosen thermal comfort, and basically a cost-effective, non-disruptive installation, and with a typical payback in 2 to 3 years. So again, that fits in nicely with the aims of the MPA Interreg Energy Priority. And the final pilot that I'll feature today is our colleagues in Iceland. And this is the Energy Agency in Iceland, Ziggy Fridleifsson and Ragnar Asmundsson. So just to give you a little bit of context, that's a picture of Iceland. This is a country which is 99.9% renewable energy. So you probably wonder where they need this extra technology. But if you look at this little dot up here, this is the island of Grimsy. And up here, if I just, so 99% renewable energy, 99.9% renewable heating. Of course, we know where that comes from. Mostly that comes from their volcanic hot water, which they use to heat up most of the country. Although there are cold spots, and these cold spots still are reliant on more traditional methods of heating. And this island up here, Grimsy, is one such place. You can see Grimsy here, fairly remote place, but it does have a small village here with a few hundred people who live here. It's got a church and shops. And the idea was that this island is completely dependent on diesel for heating and electricity through diesel generators. So that's their consumption of diesel. Absolutely no renewables here. They're outside the volcanic hot water sources. So the aim of this project was to try and push this island onto a renewable energy future. And you can see here, this is a picture of the diesel generators and their oil tanks, and a typical home here on the island. So I think, I'm sorry, I'll just go back here. The milestones so far. So changing the regulations, well, they had a challenge to fit renewable energy into specific agreements between the state and the energy producers on the island. So they also had challenges with the residents and by taking away their reliance on oil-fired heating and electricity. And a bit like what Robert said earlier, there is a certain amount of winning over local population that had to be done here. And of course, there were some political stuff, as you can see here. It had to introduce the plans to the residents. We had to get permits for construction. LED lights were being fitted as well. And then they had the practical equipment of buying and shipping the equipment to Grimsy. And they had to, they were erecting 2 wind turbines and 11 kilowatt solar panel initially. And of course, they landed in winter on the island, and of course got stuck in the mud and all sorts of things. I've got some pictures of that, but didn't have time to show all of that. And then they had to make an agreement with the energy company to run and serve the units. But it got quite good publicity, even though it's a very small island with a very small, tiny population. It actually captured the imagination of the main country, and the people got behind it, and they got quite a good bit of publicity. So the steps beyond SMARTRenew are to add at least 4 more turbines, offer the residents solar panels on their properties, put in a battery to stabilize the grid, blend the diesel, the remaining diesel with locally produced biodiesel, install pellet burners and heat pumps, and then take out any of the oil and heating subsidies. Because one of the things in Iceland, if you're not on the volcanic supply of hot water, which is very, very cheap because it just has to be administered. There are no fuel costs as such. Anybody who's not on that actually gets a subsidy. And so that all of the population are on the same level playing field. They're quite fortunate, really. So, of course, taking out the heating and oil and heating subsidies is one of the things they have to do with the population. Just one footnote. Our colleagues in Iceland sent us these pictures when they were working there and erecting the turbines and putting in the PV panels. The local church went on fire, and apparently the only thing to be recovered was this piece of burnt paper here, which apparently, as I'm reliably told, says in Old Icelandic, "It will be all right in the end." And I think they took this burning church as a symbol of that we should actually stop burning things to heat ourselves and supply electricity. So Icelandics have a good sense of humor. So just to finish off, we have the rest of the pilots here. I've put details up here for anybody who wants to get in touch with us to get details. So just to run through the ones we didn't talk about. In Oulu University of Applied Scientists, we had a smart heat storage combined with district heating to reduce oil use in Kuusamo, which is a Finnish town close to Oulu. And this was a large water tank, a huge water tank to store energy as in water as heat. And as we know, the capacity for water to store energy as heat is much more efficient than actually driving water down a mountain through a turbine. So it's become more and more popular as a storage, and this project was also about storage. We looked at patterns in the Faroe Islands. Bjarni combined borehole thermal energy storage with water storage, ground source heat pump, and PV panels, and he applied this on their actual Environment Agency building. So they're very much looking into borehole technology, geothermal technology also. One of the side experiments of that was to actually, in a 400-meter borehole. They're going to experiment with actually storing heat in rock down there, as well as storing heat in water. So that's an ongoing experiment. With Iceland in Norway, Iceland has been doing some work on 2 houses that are in the Arctic Circle and are attempting to be completely off-grid using a mix of renewable technologies. Now that is quite a challenge to be completely off-grid in the Arctic Circle. Winters can, as you know, be very, so that's an interesting project as well. And then our own pilot, which is really not so much about heat, but here at the Institute, we are developing and building, it's still being built at the moment, a solar PV paneled supply to 3 car chargers in our car park with a battery storage as well. So what we're doing is we're combining our grid with some PV panels to supply energy to 3 new EV chargers. As we know, we're extremely slow in uptaking EV in this country. So this is our little bit to help that. And we have solar panel combined with the grid with backup storage to run the chargers and also to run the lights in the car park. That's still being built, and I don't really have too much information on how that's performing yet because we still have a few weeks to go with that development. So I want to thank you very much today for attending and listening to us. And if you want to get in touch about the SMARTRenew project or any further details on any of those pilots, you can contact me directly or else look at the website. We're quite active on Twitter and LinkedIn and Facebook. You can contact us through that as well. So thank you very much for that. I just want to hand you over to Anu Monton, who's going to talk about the eLightHouse project, another MPA project. Anu's a senior lecturer in the Department of Civil Engineering at Oulu University of Applied Science and is a qualified architect with experience in the energy efficiency of buildings. So Anu, I'll hand it over to you if you want to share your screen.
Yes, thank you. So I think I got the screen, didn't I? Okay, so I'm Anu Monton from Oulu University of Applied Sciences. I'm educated as an architect and now I've been working in the supervising office and now 6 years at the Oulu University of Applied Sciences. And I have been working with this eLight project with two, in two forms. So I was, the latest I was just kind of following the project, and for 2 years, beginning of the project, I was working with the city of Oulu and kind of doing more procedures with this project. So what has happened before the eLightHouse was kind of leading to the eLightHouse project, which was made with good connection with the city of Oulu. So we have from 2010 increasing energy efficiency in buildings. That was the IEB project, and after that we have the RESCA, renewable energy solution in city areas. So they were not so rural areas. There had some pilot areas utilizing energy efficient solutions, and we were studying renewable energy sources, including hybrid solutions in this stage. So this was good platform also for eLightHouse. And then from 2014, we had the future buildings and renewable energy project, and there was also a pilot area working. And after that, from 2016, we have the 3 years project of eLightHouse project. So that's kind of the history back this project with the quite same co-operators with this project. So here you can see the eLightHouse project info, the key components of the project. It was mainly mainly done with the, so I'm just changing the tab. We had 6 key components. It was retrofitting of public buildings. And then we have a separate part of waste as an energy and the reuse of waste. Then we have the smart energy solution for public infrastructure and housing. This was done in different countries. And then we have different kinds of energy reduction solution for buildings and waste management. And I could say maybe the most important was this one, the raising awareness in different countries, and we were trying to find the ways to do it. And of course, the domestic energy retrofit was one of the main subjects. We have the 4 work packages here, and partners were from Finland, Norway, Sweden, Greenland, Ireland, and Scotland. And we could say the work package 1 was more about the municipal buildings and lighting, energy savings in this section. And then work package 2 was energy efficiency advice and energy saving for domestic renovation, retrofit, and new buildings. And I will have some examples more about this work package 2, as we are talking about the rural, more about the rural areas. And then we have kind of the waste package, the work package 3, and work package 4 was evaluation, validation of transnational practices. And here you can see the partners we have. So we were in Cork, in Oulu, Finland, Sweden in Umeå, city of Umeå, and the University of Umeå, Norway in Bodø, and then we had Scotland and Greenland, Sisimiut in our project. And then we have the Norland Research Institute, and let's see if I forgot someone. So here we have the partners who were working with this project. So sorry for this complicated slide, but I wanted to show you the work packages on this section. And then we have the procedures, what we done in each. And then as conclusion, we have the smart solution from each of these work packages. And there were 16 of these smart solutions. I will show part of some smart solutions which were implemented after this project. So what happened, the goal was to support and follow up the retrofit of more than 250 public buildings. So they were retrofitted, there was 5% less energy and 3% more renewables energy sources. There was maybe some problems with the renewables because we were, kind of the baseline was very different in each countries. And this procedure included 40 deep renovation also. And in private sector, we have more consultation of building supervisory authorities, and the project aims was to influence the decision makers about the energy efficiency of 2,500 houses and 2,000 new houses, new residential houses in this work package. And the aim was to gain 25% of better energy efficiency. I will show some how it could be done in different countries. And with these new houses, it was more about advice and giving advice and kind of teaching the new builders. And then we have the kind of a waste package over here. I'm not going into that so deeply. And here's the work packages and the results. It was from March 2019 for the final seminar. I will go to this energy saving in municipal buildings. So there was 2,040 around retrofitted that was done, and 2,500 houses was also retrofitted, and that was done. And we succeeded with the new houses quite well also. And we have, with the evaluation, we have 11 smart solutions piloted. So that was done in this project. We have 3 examples of here, quite simple ones, what was done in this project. So I have example 1 from Sweden. It was for energy savings in municipal buildings and lighting. I wouldn't say it's a very, very rural area, but it's kind of a rural area in Sweden, in northern part of Sweden anyway. So there was, target was to save in energy. And what was done, it was 44 buildings with improved energy efficiency. Most it was like schools or preschools. And implemented actions includes LED lighting. This was quite in big role, and then was some ventilation upgrades done and upgraded steering and control system. So more about the behavior, and we have some digital control systems in these buildings. And here are the energy saving results. Total energy saving in these 44 buildings were around 4.2%, which is quite much in northern countries. And we have to remember these buildings are not very old ones, so they were maybe not so need of retrofitting, more about needing more intelligent use of energy. And there's another example from Umeå, made by Erik Eklund and Grimsy. And this is about the energy efficiency advice, which was really in the big role in every country, and about energy saving for domestic renovation and also for new buildings. And this is something what kind of process they were doing with the new builders. It's a guidance process. It's not so easy to see with these little letters, but I will explain it to you. So there included 180 households with improved energy efficiency in this project. The actions included, they had heat pumps. This is quite kind of international way to do it. So you have in the air heat pumps, more insulation of attic or walls, mostly to insulate attic is more efficient. And of course, the behavior actions and guidance for inhabitants. And they added in this project one part of guidance. I will just read here in work package 2 of energy efficiency advice and energy savings in household. They had good results with basic actions of energy consultation and advice for individual energy saving behavior and by collecting annual data from energy companies with approval from householders. That happened in here. So after data collection, there was kind of follow-up contact. It's here, if it was needed. If there was something to about advising how to use energy, or there was some methods you could use to improve the energy use in these buildings. And clients were given individual guiding and giving professional advices of energy saving solutions and positive influence on behavior actions in energy efficiency. And they have this kind of, how could I say, discussion with the city and with the inhabitants. So this was something we were doing also in Oulu, with the Oulu city. And this had the energy saving results around 11%. So this is the last one of the examples. We are going not to Scotland, as I said before, or had the information. We are going to Ireland. And this is more kind of the practical solutions. I'm checking the time. This is also the energy efficiency advice and energy saving for domestic renovations. And there was 24 retrofit measures evaluated in this NCE Insulation Ireland project. NC Insulation is community-based, not-for-profit organization delivering energy-saving measures to home across Ireland since 2003. And those actions which were included in this project has been listed here. There was 24 of them, but I have just the most important ones listed here. It's about compact fluorescent lamps where, let's see, the next one is maybe easier. We are saving some time. Here you can see the total of numbers done with these procedures. Change of lamps, full window replacement. These measures or the things you are doing or retrofitting the buildings are quite different we would do in Finland. But you can see about what was the baseline of these buildings to retrofit was quite different as we had in Oulu. So we maybe wouldn't use the same kind of measures, but these were very efficient in Ireland. So if we are going to heating systems, so we have the insulations here, and we have the air-to-water heat pumps and air-to-air heat pumps. About the results, you can see about 30% in this table, and there's more list about the procedures to done. Well, maybe here you can see attic insulation and roof ventilation, and the solar thermal, but not so much in this project. And then there was, as conclusion, also the impact of different retrofitting measures and how you get the savings, what percent, and the annual savings in euros. So this was quite important to see. So what it really means when you are doing something energy efficient retrofitting for the older buildings. I'm not going so study this more carefully. Maybe you can get the material from here. You can see what has been done. I have just 2 points here with the kind of the basic measures done. So here is the cavity wall insulation and the roof, maybe not the roof, sorry, the heating controls upgrade done in these buildings. And after this, the effectiveness about the air to water heat pumps was just kind of enormous in this project. And the 2 slides I have for the last ones, I have some pictures taken from Iceland. So you can see the heat pumps done. So this is something we couldn't do maybe in Finland because there's not power enough to our buildings, not in every case, to cover the need of energy, but this was working system in Ireland. So this was a new or the older area with the retrofit of energy heating systems, and mostly it was air to water heat pumps done in this project. And some pictures from the project. So what I could say from this project was maybe that we have to study carefully about the baseline we are starting. So the meanings to reduce the energy use is quite different in different countries or areas, depending about what kind of buildings there has been built. If there's a picture of Greenland, we have to think about these buildings has been built as they would be situated in Denmark with those rules. So they are totally different of what we have been doing in northern countries, in Sweden, Norway, Finland, with the insulation and all the structural solutions. And this is from we are underneath the swimming pool over here, having the most efficient, energy efficient heating system for the pool. This picture of insulation work retrofitting done in Greenland, and we had quite a lot of seminars in this project. And here's a picture from Ireland, a new heating system center they had done in this more rural area. Thank you for your interest. I hope you got something out of the slideshow. So I will hand it back to Robert. You need to open your microphone.
Sorry, you're on mute there, Robert.
You're still on mute there, Robert.
Okay, sorry. Yeah, probably best just for me is to keep me on mute. Really, that's really got our three speakers, and we've sort of we've come to the end really of this part of the session. The only thing left is basically to look at some sort of Q&A. I'm just going to go through some of the Q&A that's come up in the past, and if anybody sort of wants to come in, please do just raise your hand. Just some questions here have come in. We'll just go through them. So from Andy Frew, is any oil boilers too powerful? Looking at condensation, and they can speak to you offline, but effectively the oil boiler was sized to work with the house without the heat pump, just as a last case scenario. Looking at capex and the air source heat pump, did we include the extra cost of rods? Yes. I haven't actually articulated that in the conversation. I'm more trying to sort of show the fact we had to put in extra insulation and the cost of that. But yes, the overall, the cost of the hybrid heat pump was €3,500. Yes, it did include, it does need to have extra additional size rods, which we will all be putting together in the final report. Same issue for our return on investment. With regard to the power generation, it's a research project which really is looking at not just the benefit to the customer, but the benefit as a prosumer and how much it can export out onto the grid. So the our associate partner there is carrying out additional research. In other words, there's going to be benefit not just to the household, there's going to be benefit going back to the grid. So we need to see that in this fullness of time before we can look at the return on investment. The battery and PV was powered by direct electric heating, and we'll be putting the results of that into the final report. In terms of integrating the suitable supply tariffs, yes, there is a power shift tariff, which is basically you pay a peak amount between 4 and 7 p.m. I don't actually think is it available anymore, but the clear thing has to be we have to see some sort of tariff change if we want to see electrification of heat. We actually seen there this morning as Octopus Energy is running a pilot with National Grid where they want to get some of the 1 million customers to see can they do some behaviour change on this issue of power shift between 4 and 7 and see what that can do. So customer behaviour and how much we use, and we try to reduce the peak demand whenever we all need electric between 4 and 7 is a key part of how we can deliver more flexibility onto the electric networks. So very good question, thank you. Question from Helen, I'm going to sort of bat that one towards Anu, if you maybe answer that one. And then there's another open question there as well. So maybe we'll just sort of go through them here in slow time. Anu, there's a question here about the Energy Efficiency Advice Project. How is advice given and were there house assessments carried out? If you want to talk about your house, I can sort of talk briefly about the Handiheat as well, if that's relevant. Anna, if you want to come on.
Oh, okay. Yeah, I was reading to Natalia's question, what are the main differences in building retrofit? Is that okay? I will answer first.
You answer Natalie's and then I'll answer this. Yeah.
Sorry. Yeah, so there was a question about what are the main differences in building retrofit solutions conducted in Finland and mentioned island countries. So I think mainly it was the use of renewable energy. So we didn't have so much we didn't have so many kind of persons to use to improve the use of renewable energy because we already did it kind of the quite good amount in the new buildings and the old ones also. There is something to do also, but not as much as in the island countries. And then it was about the insulations, because one one thing we are kind of now waking up again is that we have to have good insulation. And we already had quite good insulation kind of in northern Finland and in Sweden, and there was maybe some lack in island countries, could I say like that. So we didn't have the same means to use of island countries, and we didn't get the same amount of good thing from the air pumps. We are using those, so but it wasn't so as effect as we would like to have in our country. So mainly it was about the baseline, what has been done and what has been done. Like we have our air temperature inside is always 21 or 22. It's night is 21, daytime is 21, or it's getting 25 in summertime because we are having so much insulation and 2 big windows. But as we learned, it's not the same maybe in every country. So we have the different kind of standard with this one. But I think it was really good lesson for us what to do. And now in last 2 months, we have some, sorry taking this long, but we have this enormous price. It's like 3 or 4 times prices in electricity and gas. So now we are waking up about the rural areas, what we are going to do. They used to pay like 100 euros per month for electricity heating, and now they are paid 800 or 900. And what they can do there, they don't have so much, is more insulation to cut down the prices, because they are not going to cut down, maybe they're getting to 18 degrees, but not 21 degrees inside. Sorry for taking this long.
No, I can echo that, because we've got we're just starting off all our pilots. We're pulling in a lot more data, but I'll give you 2 examples. I've got a tenant who likes 19 degrees, our householder, and that's what she's happy with. Her electric bill's £5 a week. We've got, but more generally, people like to see temperatures in around 21 to 23 degrees in their living room. And there's no right or wrong answer here. And you have to be respectful of a householder's wishes for what they want. And we have to try and work around that. The clearly big thing for us is that we need to do a certain amount of energy efficiency measures. We believe what we're spending under £10,000, getting their tightness down between 5 and 7, from between 10 and 12, and keeping the house that bit warmer, that you're only losing 2 degrees at night, is the good basis before we start all these low carbon technologies going forward. But education is a key part of it. How people used to heat their houses, how they're not even using the conventional boilers right, is all part of it. I just want to go through some sort of points of some people here. So there's a question there about tariffs at the moment in Northern Ireland, which is all I can really talk about. We are working with the largest regulated power supplier, Power NI, and in future projects they are working and giving us time of use tariffs at the moment. We did have an ambition to look at agile tariffs, but agile tariffs puts part of the risk onto the householder. And in current conditions, it's really the same way in life. Do you want to have a fixed term mortgage or a variable mortgage? And at the moment, with the high uncertainty, we do believe time of use, which is effectively a fixed term, gives you better value. But we do think that we do need to see tariff change before we can go for any form of electrification. Question about looking from oil to electric, it was really more looking at the amount of generation as in the island of Ireland. At the moment, I took quick figures there. There's 4 gigawatts of installed renewables. The Irish government has put in the Climate Act to put an extra 5 gigawatts. The Northern Ireland, I think, is 1.5, 1.6 gigawatts, and they've got an ambition to put an extra gigawatt. So yes, there's an ambition to use a lot more wind, which is a lot of wind in Ireland. About behaviour change, but yes, spot on. Behaviour change is a key part of it. What we done on Handiheat, we explain to tenants what to do. We get their consent. It's all about them, as in we want to look at the behaviour. We want to look at their acceptance or not of this here. And we also brought in a behavioural researcher from Ulster University, and her findings, she's actually publishing a PhD report, but we'll be putting it out in our final report as well. And we do believe that independent analysis from a behavioural scientist or advisor is very, very key, as opposed to ourselves and our project managers. We'll be speaking to the householders maybe twice a week. Question there about next about domestic, but I just read it out here, because I'm not an expert. Domestic turbines can cost effective, but remember, it's not only to satisfy your needs. So whenever the one doesn't blow, in other words, next sort of highlighting you need some sort of base load. So you have to have a mix of energy use. Questions from Emma. Who is going to pay for and deliver? Thank you, Emma. Who's going to pay for and deliver this retrofitting of upgrades to meet net zero? Yeah, it's a key question, Emma. The cost involved is profound. We, in reports, the houses have done, and reports that DFE have done, have indicated that we need to see a doubling or trebling the amount of work we're presently doing. We see anecdotal figures that the cost of climate adaptation and mitigation in Northern Ireland alone is £1.3 billion per year from 2030s. And context of block grant is about 14 billion. So you're talking about 10% of that. There's going to have to be a mixture of grants and self-pay and able to pay. But you know, we have to be very look at the fact that fuel poverty levels, you know, based on prices of energy, based on household incomes, which are both one's gone up, one's gone down, and then the energy efficiency. Based on all that, there, in all probability, our fuel poverty will be going up, and so the fuel poor, the working poor, the just about managing, that category has to be well considered. And yes, there is an able to pay, but at what point is able to pay there, we do not know. And is it realistic for somebody, no matter what their salary, to pay out £4,000 to go and buy a heat pump whenever they can buy an oil or gas boiler for about £1,200? So at that point, do we have to engineer the market? You would have thought yes, because if we want to do this here. And again, today we're looking at rural, so we're fixed very much in electrification. And the more urban areas, we were looking at to see where hydrogen is going to be part of the mix. Again, this is rural, so focus more on electrification. But it's the affordability to the customer, to the householder, is very, very important. Whether it's social housing paying the asset manager, whether it's owner occupied paying the householder, somebody has to pay the bill. But in context, there's a lot more to think about. There's all the benefits. We've got, you know, and these are implied benefits that we don't talk about. We're always fixed with money. We should be thinking about, we're going to have the jobs will provide green growth, will provide a stronger economy, will provide more apprenticeships and more education and more opportunity for young people, more jobs effectively. We want to see if we've got better or less use of fossil fuel, we're going to have better air quality. We're going to have better health benefits. We're going to have less burden on the NHS. And actually that's articulated by the Committee of Climate Change, which says that by the 2040s, all this investment and all this spending from the 2030s will turn around and see cost savings. So they see by the end of this road, you know, the benefit and cost will be equal. So it's not just about the spend. Yes, the spend is about here and now. Who's going to spend it now? But there is benefits to all this here. Don't know whether that's the right answer, but yeah, that's how we see it. If there's nobody else for anything more, I think really that brings our session to an end. I'd like to thank our panelists, Anu, Nick, and all the hard work behind the scenes from two people you probably don't hear very much about, as Maria and Amy. Maria's hiding behind the moderator. She's the person that puts us together. All the social media stuff you see is all thanks to Maria. So a big thank you. Yeah, Maria's finally showed up there. A big thank you to Maria and Amy for assisting her for doing this here. We want to look forward to our next webinar, and we haven't got a date yet, have we, Maria? I'm just looking at you here. No, Maria's not going to talk to me. She's on mute. No, we haven't got a date agreed yet, but we're going to have this, our next webinar session. We will be posting details of that there, and thank you very much.
Brilliant.
So thank you.
Thanks, everyone.
Thank you so much, folks. Thank you.
Thank you.
Has Nick left, or do we all leave now?
Everyone did leave. Thank you, folks. We'll just wait for everyone to leave, Robert. It's okay.